All right, we're moving along and we're now on this section which is about inscribed angles. So I'm going to quickly go over what an inscribed angle is and the important things to know, at least according to this book, and then we're going to go over these practice problems. Okay, so let's look at my phone over here. So what does it say an inscribed angle is? An inscribed angle is an angle whose vertex is on a circle and whose sides contain chords of the circle. So let's look at this figure over here. So this angle right here, angle B, is an inscribed angle. Why is that? Well, the vertex is on the edge of the circle, okay? And then these are chords of the circle. Okay, so this is the inscribed angle. All right? And what's important to know about the inscribed angle? Well, the inscribed angle, the measure of it, is half of the measure of the central angle. Okay, this is a central angle, by the way. Remember, central angle, the vertex is at the center of the circle, and the sides are radii of the circle. Okay, so again, this inscribed angle is half of this central angle. You can even imagine, right? This one, if you extend it further back, like, okay, let me use my two pens as an example. Okay, so here, right? If you want it to still be at A and C, you extend this back to the edge of the circle. The angle, you can imagine, is getting smaller, actually. So it makes sense that it's half of the central angle. Okay, and if you remember, the central angle is equal to the length in degrees of this arc over here. Okay, so therefore, this inscribed angle is also half of this arc, measure of this arc in degrees as well. Okay, so that's what this is saying over here. All right, now some corollaries that just result as that happen as a result. Okay, if the let's just read. Two inscribed angles that intercept the same arc are congruent. Makes sense, hopefully. You can think about it in your own time if it doesn't quite make sense. Okay. Corollary 2, an angle inscribed in a semicircle is a right angle. This totally makes sense, and this is easy to explain because, remember, this inscribed angle is half of the intercepted arc. This arc is half a circle, which is 180 degrees. So what's half of 180? 90 degrees right there. And corollary 3, if a quadrilateral is inscribed in a circle, its opposite angles are supplementary. And this makes sense as well because let's look at B and D, okay? These are opposite angles, okay? What arc does this inscribed angle B intercept? This one over here, right? How about this inscribed angle D over here? It intercepts this arc. This whole circle, notice, is 360, so the sum of these two angles should be half of 360, which is 180, so that's why they're supplementary. This one's easy to explain as well. Okay? Actually, this one's easy to explain as well, but I would recommend that you actually think about it if it doesn't make sense to you, because if you work through it yourself, if you struggle with it yourself, you're more likely to retain it better, actually, versus me explaining it. Okay, now let's go through the problems then. So we're given this figure over here, okay? What is the value of y? Where is y? This is a central angle, right? So, by the way, you should try these problems first before watching how I think through them and to get the solution from me. This angle is a central angle. So what's the arc that it intercepts? It's this one. This central angle should equal the measure of this arc in degrees. So it's 48 degrees. Okay? 48. What is the value of x? X looks like it's an inscribed angle, right? What's the arc that inscribes? dB. So it should be half of this. What's 48 divided by 2? That is 24. Okay, these are starting easy. What is the value of W? Where's W? W is here. This is an inscribed angle, clearly. What's the arc that it intercepts? AB. AB is a diameter, so it's half the circle. So what does that corollary say? This should be 90 degrees. Or if you don't remember that corollary, this is 180 divided by 2, 90 degrees. Okay. What is the value of Z? Where is Z? Z is a arc. Okay. Now how can we find what Z is? Well, we can look at AC plus CD plus DB is 180. It's half a circle. So 100 plus 48, that's 148. So 180, this one should be equal to 180 minus 148. And that is 32 degrees. That's one way to solve this. You could probably have looked at inscribed angles, central angles, and all that as well, maybe. I don't know, but that's what I saw right away. Pick the easiest way. I think this is easy, at least for me. Okay, 5 and 6 refer to this figure. Quadrilateral is inscribed in a circle. What is the value of x? Okay, so what does that corollary say? This angle and this angle should be supplementary, so they should add up to 180. Therefore, x is 100. Okay, last one. This is actually pretty quick. What is the value of y? Where is y? Y is this arc over here. How can we find that? Well, this is an inscribed angle, right? 75. So 75 should be half of 70 degrees plus whatever this measure is. So let's write that down. 75 degrees is equal to half of 70 plus y. Okay? And then we can solve for y, right? So this is 75 times 150 is 70 plus y. So y is equal to 80 then, right? Answer is B. Okay, that's one way to solve it. There's probably multiple ways you can think through this, but that's the way I saw right away. Okay, and that's it for this problem set. It was quick, and this section was not too hard, honestly. So hopefully you just memorize that inscribed angle is half the intercepted arc or half the central angle. That's really the key concept here. All right, hopefully this is good practice though, or a good review. Please like and subscribe as always if you found this helpful, and hopefully we'll see you in the next video as well. Bye.